Hi, I'm happy to welcome you back to my channel. In the previous chapter, we talked about comments, we got introduced to that part, we went through our environment, got to know stuff about these buttons and all of that. We also talked about documentation for a beginner. When we were talking about comments, we did something like this. I just put a forward slash and an asterisk. I wanted to comment out this for loop. Then I go to this place, I will do an asterisk and a forward slash. And then I've commented from line 2 to line 4. When you start getting your hands dirty with Dart and with Flutter, you may not really have the time to be doing all these except when you want to do an inline comment. Let me just undo what I have done. Assuming you have something like this, this is an inline comment. So this is the only scenario you'll be needing this. Majority of the time, whenever you will be doing comment, you will be doing something like this. So assuming I want to comment from line 3 to line 5, I'll just highlight everything. If I am on Mac, I will hold down my command key. Or if I'm on Windows or on Linux, I'll just hold down my control key. Currently, I'm on Windows, so I'll hold down my control key. I'll hit on the forward slash, and then it uses a single line comment to comment every single line of code that I have selected. I can still do it for a single line like this. Depending on the number of lines that I select, it doesn't really matter. This is more like a shortcut. I mean, it's more like a keyboard shortcut that you can use while writing your code and all of that. So assuming this guy is already commented, I can still undo what I have done. Like instead of saying Control Z, I mean, you use Control Z to undo, just like we talked in the previous chapter. I can still highlight again. I mean, I want to uncomment it now. Hold my Control key. That is because I am on Windows. If I am on Mac, I'll hold my command. And if I am on Linux, I'll still hold my Control. And then hit on forward slash. And then it gets uncommented. That is just one addition I would want to show you as a beginner. That's that about comment. I implore you to go over to the previous video if this is the first video you are watching. This is actually the second chapter of our DAT course. We already have one chapter that we did, and we talked a whole lot about stuff. It's cool if you can spare your time to just go back to the previous video, get to watch it before coming to this current video, so that it will help you to keep abreast of everything we are doing, right? In this chapter, which is chapter 2, we are going to be getting our hands a little bit depth into the basics of that programming language. Before we start, what I'm just going to do is that I'm going to comment this guy, and then I'll push it down. I know that we've not been able to talk about what this guy does, but don't worry. Whenever we get to functions, we are going to discuss every single thing about this void and this main, and I mean this block from line 1 to line 10. You know, everything we are writing has been inside this void main. So when we get to functions, we can get to discuss about this. Don't really bother. It's not a big deal. So for now, let's just go with our flow, right? I'm going to write our first line of code, which is going to be something like string my name equal to Emmanuel. This is how a typical that line of code will look like. I mean, the most basic. We are going to talk about the component. On this left side of this line 4, the first one we saw is string. So string is showing us what we call the data type. We are still going to talk more about data type in this chapter. Then this guy is the variable name or the identifier, which is what my name. So instead of saying my name, I can still say his name. So but let's just stick with my name, right? Because my name is Emmanuel. So this statement on line 4 is mainly composed of 3 parts. This guy, then this guy, then this guy entirely. As a rule of thumb, every complete statement in that is ended with a semicolon. I mean, whenever the compiler sees your semicolon, it says, oh, this is the end of the statement. Cool, fine. The code we commented inside this our for loop where we had this print hello I plus 1. You can see that it stopped with a semicolon. Whenever we use this equal sign, it stores this data inside this my name. The first word on the left side says string. Whenever you write a line of code in that, especially when it has to do with storing data, you will want to indicate what type of data are you storing, right? What we are doing here is that we are storing this string Emmanuel inside this my name, so that every time we call my name, we know that my name contains what? Emmanuel. So this is the data type of what we are storing. Then this is the identifier or variable name. An identifier is a name tag that is given to any type of data, right? For instance, you can identify me by my name, right? My name is Emmanuel. Anytime somebody says, hey, Emmanuel, I'm more likely to turn back because that's my name. And then that's my tag, and then that's my identifier. It's something that is being used to identify me, right? Okay, just imagine a labeled container or a box. On the box, we write boldly my name. Then inside the box itself, we put in this guy, Emmanuel. Every single time we bring that box and we see, oh, it has my name written on it. Whenever we access that my name, we know that what it is going to give us was Emmanuel. Then this guy is called the data type of my name. So it is showing that my name is what? A string. A string is just something you have inside food. Any type of data that comes inside food is a string. Apart from single quotes, you could always use double quotes too to denote strings. However, there is a rule. The rule says that if you start with a single quote, you must end with a single quote. If you start with a double quote, you must end with a double quote. You cannot start with a single quote and end with a double quote, and you cannot start with a double quote and end with a single quote. Let's say we have a second string. Your name is equal to Daniel. Okay, this time around I'm using double quote, right? So you see that everything is cool. However, let me remove this double quote and put a single quote, and we are going to run into an issue: unterminated string literal. So the thing is that the way the dat compiler works, like we said in chapter 1, we talked about how the compilation and execution happens with our code, right? We said that it starts line by line. It starts from line 1, finishes everything on this line 1, comes to line 2, oh, nothing is there. It jumps to line 3. It starts from this string, goes like this until it meets this semicolon. Whenever it meets this semicolon, it will know that this is the end of this statement. Then it will come to line 4, start evaluating this guy. So the thing is that while it is going through this line 3, whenever it sees this first single quote, it now assumes that, okay, every other thing I'm going to see till the next single quote is what? A string. However, if it is on line 4 and it sees this double quote, it will now assume, okay, every other thing I'm going to see till the next double quote is going to be what? A string. When you now start with a single quote and somewhere here you give it a double quote, initially the first one it saw was a single quote, so it is expecting you to give it the next single quote. And you see, if we put a single quote here, everything goes fine, and then we are now having a manual and a double quote. There is one thing that this particular rule helps us with. For instance, look at this statement now. String statement. Let me say it's already code. If you look at it, you see there is an issue, even with the colors and all of that and everything, right? So just like we said, when the compiler comes to this place, he looks at this. Once he sees the first opening quotation mark, either single quote or double quote, it now prepares itself that it is going to see a string, and it is always looking out for the next single or double quote depending on whichever one you start with. So we now started with the first single quote and we have it. Somewhere here, we now put another single quote. So whenever it comes to this place, you say, oh, this is the end of the string. It doesn't really know what these guys are, even though it is still included. Even this single quote that is here, it doesn't know it again. And that's why it is telling you that it is expecting to find this guy. So it's expecting you immediately after you close this guy, you should give it the ending of a statement. You can see that this guy is gone. Then from here to this place, it doesn't really know what you are saying again. So the idea to overcome this is that if for any reason you are going to have a single quote inside your string, then you should better start off with what? A double quote. And if for any reason you are going to have a double quote inside your string, you should better start off with what? A single quote. Back to this statement now. Since I know that I'm going to have this single quote here, so I'm just going to start off with what? A double quote. Since I start off with a double quote, whenever the compiler comes to this place, it sees this double quote, it say, okay, every single thing from this place till the next time I'm going to see another double quote is going to be what? A string. Whenever it sees this single quote, it say, oh, I'm going to ignore this because what I saw first was a double quote. And then it is going to expect us to give it what? A double quote, to denote that, oh, this is the end of the string. So this is one funny thing you are going to need to know about using single quotes and double quotes. So let's take another one where we can say string statement 2. Let's call this statement is equal to his name is Emmanuel. So you can see that everything is fine, because we know that we wanted to put Emmanuel itself inside double quote inside the string. So we are going to start off with what? A single quote, and then we end with what? This single quote over here that I'm just going to highlight. So this is the end and this is what the start. So these are the things you need to know about the string data type. As a means of revision, don't forget we said that first of all you start with the data type. What type of data do you want to store? In this case, we want to store a string. Cool. That data you want to store, what do you want to tag it with? That is the identifier or the variable name. Then you write the variable name. Then you put in an equal sign to show that, okay, I want to assign this guy to this guy. And then you put in your data. So every single thing, line 3, line 4, line 6, line 7, they all follow the same procedure. Another statement we could want to write here is saying int number 10 is equal to what? 10. And then I can still say int another number is equal to let's say minus 21. So just like you know from your basic mathematics, an integer is just a whole number, whether it is negative or positive. An int is another data type that represents integers, whether they are negative or they are positive, as long as they are whole number. And you can see an example of how we do it the same way we did for string, right? This minus 21 is a data on its own, but both of them, unlike the previous one we've treated before, this time around they are integers. So first of all, you indicate the data type, which is int. Then you indicate, okay, what do I want to tag this with? You have a box, you bring 10, you put it inside, you label it number 10. So when I now come and I see, oh, this is an integer and its name is number 10, that's enough for me to know what is inside, because I've seen that, oh, this is an int. I can access it with the word number 10 written together. We have discussed two kinds of data types. So another one we can have is a boolean, which we denote by bool. You can say bool is a fair guy. So let's assume I am a fair guy, right? I can say is what? True. So booleans can either be what? True or false. So I'm just going to put a comment here and say string data type, and over here I'm going to say integer data type. Over here I'm going to say boolean data type. So a boolean will only have two values, either it is true or it is false, and in that the data type is denoted as bool. BOOL. We are saying, oh, is he a fair guy? And we are saying it is true. We could actually say false, right? If we want, say false. And then notice that it is always in small letters, right? You're true and false. So you can't have something like that is not going to know what you are saying. So it just has to be lowercase. Another data type we might want to consider is what? Double, right? Just like we have integers, decimals are called double in that. So we can say double. Let's say any decimal. You can say it is 0.234 blah blah blah. So any number that has decimal is denoted by double as its what? Data type. So that's that about data types. We have a lot of them. We discuss only string, int, bool, and double. We have the list data type, which we might be talking about in subsequent videos. We have set, we have maps, which you call dictionaries in Python. We are going to talk about these ones in future videos. I do not really intend to make this video longer than necessary. You take out your time, just go through them. I mean, you could just Google online and what they mean and how to use them. But in subsequent videos, when we are going to start dealing with those guys, I'm still going to take a little bit of time to explain them a bit. So that's that about data types. Let's talk a bit about variables. It's almost the same with an identifier. So this my name, your name, statement, statement 2, number 10, another number, all of them are what? Variables. Think about the meaning of the word variable, something that can vary. The meaning of the word vary is something that can change over time, right? On line 11, I said int another number equal to minus 21. Because this another number is a variable, I can still come here and say another number is equal to what? 100. I'm trying to reassign this data 100 to what? Another number. So that is why we call it variable, because the data can change over time. And the same thing happens to the rest of these guys. My name is no longer Emmanuel. My name is now Nana. My name in memory now is now going to hold Nana instead of Emmanuel. So these guys are an identifier, or you call it a variable. But a variable in the sense that it can change over time, and then an identifier in the sense that this is the label you have on particular type of data. Let me remove these guys so that we have a clean slate to work. What if I say string class equal to class 10? Why can't I use class? It's shouting undefined name class instead of saying class. So what if I say again string else equal to second condition? As you can see, it cannot go. So this brings us to what we call keywords in that. So I'm just going to write a comment keyword in that. So keywords are words that you cannot use as variable names. You can use them as identifier. The reason is because that has already reserved these words for something. Just like this our string now. String is already reserved in that for denoting the data type of anything that comes in between either double quotes or single quote. We also treated integers, right? That word int is already reserved for any type of data that is a whole number, whether it is negative or positive. That already owns this word, so you cannot be able to use them as identifiers. If I hover on this class now, you see undefined name class. Okay, if you can see our error, it says class can't be used as an identifier because it is a keyword. Try renaming this to be an identifier that isn't a keyword. When we start doing object-oriented programming, we start dealing with the keyword class. For now, just know that class is a keyword, and the reason we can't use it as a variable name. So there are a whole lot of keywords. For instance, I can't say double if is equal to 0.56, something like that, because if itself is what a keyword in that. If is used when you write statements, if and else, and all of that. So these things are keywords. They are already reserved inside that. You can't use them. There are a whole bunch of them. But as we keep going, you're just going to be taking out little time, maybe 30 seconds to a minute to explain what they do and all of that. There are a few other keywords in that are very important. Basically. So I would also want us to talk about them before we call this chapter a wrap. And I'm just going to write it out in a comment. So the first one is going to be var. Second one is going to be dynamic. The third one is going to be final. The fourth one is going to be const. Well, let's include late. Let's talk about these 5 keywords. So initially we've been doing something like this: string my name is equal to what? Emmanuel. So that has this powerful ability that even if you did not infer the type, you could mark it with a particular keyword, and then that already knows that okay, you don't know the data type of this data initially, and then it is going to look out to be able to ascertain the data type. Instead of saying string my name equal to Emmanuel, I can say var my name equal to Emmanuel. So I'm just going to comment this guy. So the var keyword stands for variable. So assuming you are not sure that Emmanuel is going to be a string, what you could do is to denote the variable type as var. However, there are rules for this particular keyword called var. For instance, let me try reassigning this name. Assuming my name is no longer Emmanuel, my name is David now. So I can say my name is equal to David. You can see that everything is cool. What if I say my name is equal to 10? Then there is an issue. Let's hover on it and see what happens. A value of type int can't be assigned to a variable of type string. So what happens with the var keyword is that initially you don't know the data type you want to store. So when you denote your identifier with a var keyword and say, okay, this is a variable, that is going to look out for the first assignment to that identifier. So on line 5, immediately that sees var, it says, okay, I am going to look out for the first assignment of my name. Any data type that is first assigned to my name is going to be the data type of my name, right? So on line 5, as you can see, that we have first assigned Emmanuel, which is a string, to my name. It holds onto a string as the data type of what? My name. You can actually decide to reassign my name, but it must be within that same data type. As you can see, we have reassigned my name to David. I can still try to reassign it and it will still work. I can say my name is now equal to Nana. So as long as everything is within that same data type, you are good to go. The only problem is when you now try to reassign it outside another data type, that is going to say no, because the first data type assignment that you gave to it is a string. So that variable is going to continue as a string all through its life time. The second one we are going to talk about is the dynamic keyword. Let's come down and say dynamic my name equal to Emmanuel. So let's do the same thing we did with var, and then we say my name equal to David. Everything is fine, and then we say my name equal to 10, and you can see that everything is fine, right? The dynamic keyword goes outside the limitations of the var keyword in the sense that we are not really sure that this data type is going to be consistent. That this variable is going to maintain a single and particular data type throughout your program. Then you are better off marking it as what? Dynamic, because you can be able to switch the data type of that particular variable, unlike the var keyword, which will stick to one data type. So this is the difference between var and dynamic. You should try as much as possible to avoid the var keyword and the dynamic keyword, but if you find yourself in a situation whereby you just have to use them, just like we are going to see in subsequent chapters, they are there for you to use, right? You just go ahead and use them. The reason I told you to avoid them is because they consume memory. When you say string my name is equal to Emmanuel, that already knows that okay, what you want to store is string. It's just going to make out that space in memory just to store a string. But then when you now say var, that doesn't know exactly what you want to store. So it has to make out memory for an int, it has to make out memory for a string, it has to make out memory for a boolean, it has to make out memory for almost all the data types that it can offer, right? And it's not really cool. That is why we say that it leads to consumption of memory, which is something you don't want to do. When you are dealing with var, it has to make out this memory for storing this guy, and then when it sees the first data type, then it says okay, this is data type I'm going to be using. But then dynamic is even worse in the sense that that will have to make out space for even the fact that it is still going to change from one data type to the other. And these data types, memory allocation for a string is not the same memory allocation for an integer. It's not the same memory allocation for a boolean and all of that. So you should just try as much as possible to avoid the var keyword and the dynamic keyword. Let's talk about final and const. First of all, we need to know what is a compile time, and let me just put it inside the comment. I will say compile time and runtime. So we may not be able to grasp fully the concept of compile time and runtime because we have not started writing code that we can compile first and then we click on something and then something happens. But I'm just going to try and give a little overview of what it is like. Then we are still going to talk about it in subsequent chapters. In fact, I'm just going to put it down on my note that I'm supposed to talk about compile time and runtime future videos. So one thing to understand about compile time and runtime is that compile time is the time your compiler converts your English code, your code in English language, to readable machine code that your CPU can understand. Then the runtime is the time that the actual code execution occurs, right? This is how I want you to picture compile time and what run time. So now that you know what is compile time and runtime, let's proceed to talk about final and const. Whenever you mark a variable as final, it is going to be evaluated at runtime. But whenever you mark a variable as const, it is going to be evaluated at compile time, right? And you know that the compile time comes before what? The runtime. So to be able to explain how the final keyword behaves, we are going to be making use of a class called the datetime class. And inside that datetime class, there is a method called now. Just as we are going to discuss in subsequent videos, every single time a function comes inside a class, that function is called a method. So inside the datetime class, we are going to access the now method. And what does this now method do? What it does is that it gets the current time. For instance, as I can see my screen on the bottom right, you see that what I have here is 8:17, Sunday, 16th February 2025. What the now method is going to do for you is that whenever you execute it, it is going to grab the current date and time. I think starting from microseconds, milliseconds, minute, hour, and outwards. Let me just say final get current time is equal to date time dot now. The first meaning of the final keyword is that you cannot reassign it, right? You can't reassign this get current time to any other thing. For instance, I can decide to try get current time is equal to, let's say, maybe date time dot UTC. I mean, you can see UTC over there. It's one of the methods inside the date time class. And then we are going to get an error, and it says, let me hover on it. The final variable get current time can only be set once. So the first meaning of final is that the variable that bears that final is only going to be set once. You cannot reassign it after you have set it. So the second meaning is that this guy is going to be evaluated at run time. Remember, we discussed about compile time and run time, and we said compile time is when our code is compiled and transformed into a machine readable code and then goes through some series of processes before it gets to the CPU. It is going to get into the CPU as zeros and ones, and then the CPU takes these instructions and then executes it. When our compiler comes to line 14, it compiles it, then sends it out. So when the CPU receives it, it says, okay, you want me to get the current time now, and it grabs that particular time at that point when it wants to run it. This is the actual meaning of final. The first one is that you cannot reassign it after you have already assigned it. Two is that whatever thing that is going to be stored inside the final variable, it is going to be evaluated at runtime. So let's look at something like const result is equal to 2 plus 4. We all know that 2 plus 4 is 6. There is nothing big about adding 2 to 4. It's just there. Everybody knows that it is there. It is called a constant. You can remember the constants you treated in high school, in your colleges. You can talk about pi, which is 3.14, blah, blah, blah. You can talk about the diameter of the earth. So all these things are what? Constant. Like they are just there. Everybody is aware that they are not going to change. So that's the idea of what? A constant. Something you know that it is not going to change throughout your code. And these things, they are evaluated at compile time. So once your compiler comes in, it's going to sum up this guy and then store it in result and hold it in memory throughout your program. This is the major difference between const and final. So the next one we want to talk about is the late keyword in that. I'm going to give you an overview of what the late keyword is and how it works. Let's use my name again. We've been using my name all this while. So we could just say late string my name. So you see, we are not initializing it. We are not storing any data. So we are just declaring that there is a variable and that this variable is going to what? Hold a string. However, whenever that sees late, it says, okay, you don't have this variable initially, right? You remember that what we've been doing since is what? String my name. We declare the variable name or the identifier name, and then we declare what is this thing going to store, right? It is going to store the string Emmanuel. But this time around, we don't have Emmanuel initially. We don't have the data we want to store initially. But then we know that this data is still going to store a string somewhere in my code at runtime. So that will always expect value for a late variable at runtime. So when you use late, you are promising that, okay, I don't have this thing now, but I'm going to give it to you whenever you need it. The problem now arises because at compile time, line 10 is going to pass. Everything is going to be okay at compile time. Then during runtime, when your CPU is now executing zeros and one, it now looks out for my name and you have not initialized my name. I mean, you have not maybe done something like my name is equal to David. Then there is what is called a late initialization error that is going to occur. That late initialization error, it is more like that shouting at you and saying, but you promised me that you are going to give me value for my name when I will need it. Now I need it and you don't have it. Stuff like that. So that's that about the late keyword. That's that about the var, dynamic, final, const, and late. But then we've not started using these stuffs, right? So I implore you to just keep an eye on this channel. When we start using this thing, it will become very, very clear. It will become very evident, and you won't even have any single confusion on how they work, right? Cool. And then there is something else you should have observed. Let me remove these guys. Let me say my full name, right? Everything is fine. What about if I say my full name? My full name starting with capital letter. You see, the variable name, my full name, isn't a lower camel case. So let me put out that word, lower camel case. Let me delete this, lower camel. Okay, so this is actually a naming convention whenever you are writing that of Lotta, right? So the first letter of your variable name or your identifier should always start with a lowercase letter. If it is a variable, if it is a function, it should always start with a lowercase letter. But if it is a class, those ones, they will always start with what? Capital letters. If we say name is equal to Emmanuel, that's fine. But let's assume you have two or more words you want to bring in together to be able to use it to identify your data as an identifier. The first letter of the first word will always be a lowercase letter. So this is just like a rule of thumb that you see whenever you are writing that, and you have to obey it, otherwise your editor will keep shouting at you. It's not only for strings, for any single data type that you are going to be using for your functions and your variables, it must always follow the lower camel case. So in our next chapter, which is going to be the chapter 3, we are going to be talking about control flow statements. I mean, we are going to be talking about if statements, else statements. This guy, we've been ignoring it over these years, so we are finally going to get to know what this does, what a for loop is. Thank you so much for sticking around with me. This chapter is a little bit kind of long because we took time to explain a lot of stuff. I mean, we took time to break stuff down. Hopefully next chapter will not be that long. Thank you so much for sticking with me till the end of this chapter. Don't forget to subscribe, like, and then hit the bell icon so that once I drop this next video, you are going to be notified. Don't forget, if there's a way you think we can make the channel better, you feel like we can improve the stuff that I bring to you on this channel, don't forget to drop the comments, to drop your contribution, your suggestion under the comment section. I'm going to see it and I'm going to consider it. So thank you so much once again. Thank you for being my audience. So see you in the next video. Bye.